All right. Well, thank you all for being willing to present today. We'll get started with Rukaya Johaadien. Please let me know if I have pronounced that incorrectly. We'll be talking about a tool called ChatIPT, an AI tool for transforming spreadsheets into standardized GBIF datasets.
Yeah, thanks, Karen. So it's Rukaya, but yeah, very difficult name to pronounce.
I
I work
appreciate
for I work for GBIF Norway at the Natural History Museum at the University of Oslo, and I am a software engineer. So a lot of the work I do is actually sort of more data engineering. As I say, I work for GBIF Norway, and GBIF is the Global Biodiversity Information Facility. It's this big worldwide repository of data, and it has all of these nodes across the world. And in the natural sciences, there's a big push for people to publish their data, and gbif.org is like the place to do it. So a big part of my job is helping students and researchers to take their spreadsheets and clean them up and standardize them to something called Darwin Core, and then publish it onto gbif.org. So this data flow requires very specialist skills and knowledge. So you need to know how how programming works and how data standards work, especially the Darwin Core standard. And it's extremely time consuming. So you end up like having hours of back and forth with the user asking about certain bits of the spreadsheet, because when students and researchers make what they think is a nice spreadsheet or data sheets, it is not often very understandable in terms of global standards like Darwin Core. So because it requires so much time and it requires this specialist knowledge and skill set, I was kind of interested in wondering whether it was possible to make it scalable. In my institute, we have a dedicated technical team who can work on this, but across Europe and across Norway, quite often there are scientific institutes who don't have technical staff who can do this. So I was like, okay, well, is it possible to scale this? And also, I have this terrible disease that a lot of programmers have where I like to automate absolutely everything. So I was like, well, can I automate this? Let's try and do it with these really cool new large language models that have come up. So I made a chatbot, which is basically for people who don't know much about tech, who don't have technical skills and who don't know how to work with data and who don't know about data standards. And it's basically designed to replace me and take them through the data flow of cleaning and structuring and standardizing the spreadsheet, holding their hand, writing metadata for them, occasionally asking them questions, but being basically the sort of guide for them. And then at the end of it, actually publishing their data on gbif.org. So doing everything automatically and me not having to get involved at all. Right. So my first thought when I was setting out to do this was I would just be able to tell ChatGPT to take this messy student spreadsheet and turn it into the Darwin Core standard, and then I'd be able to publish that. But that doesn't work. It really does take very specialized knowledge and special skills to be able to do this. And in the end, I found out what I had to do was have a series of prompts that I feed through to ChatGPT through the API. So you start off saying, here's a spreadsheet, have a look at the data structure and write some notes about that and ask the user if you need to have a bit of dialogue and then summarize it. Then you take that summary and you pass it through to a new conversation and you say, here's the spreadsheet, here's the structure, have a look at the content and do some exploration of the content. and so on. So it works through these series of steps, and eventually it does what ends up being sort of the meat of the task, which is transforming the data and validating it and refining it. And I tried a few different approaches, but I found what works best is just to tell it to loop over itself in the prompt, say, loop over this data and keep working on it until you think it adheres to the Darwin Core standard, and this is what it should look like, and so on and so forth. Then it does a final review and publication. So I'm working with the OpenAI API. It works as well with Google Gemini, but I found the O3 model from OpenAI is the best at doing this stuff. It uses function calling, and it gets OpenAI to generate Python code, which it then runs in a Docker container and uses that on the spreadsheet on the server. So it has all the tools that I have. It can run Python code and any Python code that it wants. And I made it some like sort of helpers, like a Darwin Core field validator. It can do things like save structure and content notes and pass it on to the next agent. Critically, it can roll back if something goes wrong. Yeah, and it can go through that. So I'm now going to demonstrate it. First, I'm going to show you the sort of spreadsheet that we get from students and scientists. So you can see that there's lots of different tables with all sorts of varied data in there. And what it's supposed to look like in order to be published and to adhere to the standard that we use is like this. So a homogeneous table with individual rows describing location, scientific name or family name or whatever, and yeah, biodiversity information. So this is what the tool looks like. It's a web application, and it starts off by just asking the user to drag and drop their data file in there. And it works in different languages, because why not? It's using the O3 model, so it takes a little bit of time to go through it. So I've just like got a series of tabs open here with it at different stages that I'm going to show you. So once you drag and drop a file in here, it does some structural notes and does the data structure exploration. If it needs to, it asks the user questions, but it didn't need to at that stage. And you can see it's generating code, and it's getting the information from the code and then using that in order to interact with the user. So at the end of this, it had some questions that it asked, and the user can write into this text box over here and press enter, and then it will go on to the next stage until it has more questions for the user. And so it progresses through these different tasks. So let's go on a little bit. Yeah, this is where it's doing the data transformation. You can see on the right-hand side is the spreadsheet at each different stage. So right at the beginning, and then, oh, it's not done anything yet, so it's looking kind of the same. But if we go on to the next tab, you can see that it starts to look different and a lot more sort of regular and like what we're actually aiming for. So you can see here, it did a lot of looping. I should get it to sort of minimize this because it's quite a lot to scroll through. But anyway, it has done some things, and now it wants to do some quality check and go on and publish it. And then, yeah, it did some more stuff. It double checks with the user, and then it publishes it using the GBIF API. So maybe I should have shown you what the GBIF website looks like, but you're going to see it now. It has a little celebratory message saying your data set has now been published. And then there's a view on gbif.org. And here is the data set. I did this like just now, and I can see that it's not actually propagated through the system yet, but you can see that the metadata that it wrote is in here. And when gbif.org stop experiencing their partial outage, there will be the remaining data set there as well. So yeah, I don't think I have anything else to add. Does anyone have any questions? Gosh, I hope you guys could hear me.
Yeah, I can hear you, and
All right,
I've got a
great.
couple of questions. Um,
Why does it say share? I was sharing. Yes, stop share. There we go.
so how long have you had this? Is the does the so you use O3? Is that
Yeah.
going to be the same through time so that you don't have to change your prompts and your the way you do it, or like is ChatGPT going to be consistent enough, or will that be deprecated? I'm just wondering about like you're using these prompts. Do you have to change those prompts because they eventually don't work?
Yeah, I've been updating it. So I made this thing and then I had a baby and I went on maternity leave and I've not had much time to work on it. But I have been updating it and I'm interested in I think it makes sense because the new models have such better capabilities. I think
Right.
it's worthwhile to like keep updating it. And actually I'm interested in seeing how well it works with Gemini. Oh, well, I tried it. It doesn't work that well. O3 is still definitely doing a better job. Um,
But O3 works consistently, like they don't make enough changes to that it really matters.
well, I can show you here. Let me share my screen again.
Or does the API allow you to just query the
The
same
A
model for sure?
Yeah, the API lets you hard code let's see. Here we go. You can see here, well, I'm using the general O3 model, but before I had hard coded GPT 4.1 and I had a particular. That was the
Version.
last one I used. Yeah, 2024-0806 was the version I was using. But right now I'm finding O3 is working better.
Okay.
Yeah.
So maybe it's things just get better as you use the newer ones anyway. That you can hope.
I think so. Yeah. I definitely think it's worth trying with all of the new models.
Yeah.
They just get better. More expensive sometimes, but better.
So at this point, what are your thoughts on how good is it on the spectrum of it helps a little, but there's still a lot of manual checking and help you need to give it through like the other end of the spectrum would be, you press a button and it gives you a perfect data set. Like where is this on that?
Well, O3, I think, is actually better than me in a lot of ways. It
Wow.
knows, like, I had no idea what this stuff was. I had to ask this scientist, what is this stuff? And it knew somehow. Like it has, I don't, I have a computer science background. I don't have a biology or marine biology. I think this is marine, yeah, some marine species. And I don't know how stuff gets sampled for like marine. It knows, and I don't, and it has more context. So it was able to do a better job than I was, or yeah, a faster job. It was able to get further faster than I was in this case. And yeah, I was pretty impressed by it. I find, one of the hardest things is people actually don't like talking to a chatbot. They really want to talk to a person. I don't know why. Um, yeah, so that was is possibly the biggest hurdle. In terms of actually doing the data transformation, O3 is really, really good, at least as good as I am.
Wow.
So it doesn't make mistake. I guess it's writing code to do it, so that's why it can be accurate.
Yeah.
I've always found if you just use these large language models for um,
No, I don't let
directly, it
it.
doesn't work. You need that for things where you don't want any errors in your data translation. You need it to write code and then check the
Yeah,
code, and then that seems to work.
because if you just get it to output stuff, it can hallucinate. So
Right, and this is stuff for
the
code.
only thing it can do in the only way it can change stuff in my system is by producing Python code and running it.
Right, and then it can check itself afterwards. And is that what that looping is?
Yeah, so it's let's see if I can find that bit of the prompt. Yeah, I don't know. No, sorry, I think it's going to
That's
take too
fine.
long for me to find it. But yeah, it you ask it, so it does different looping. It produces Python code, looks at the result, and then if it needs to, it produces more Python code, looks at the result. But the looping thing is asking it to think intelligently and assess, do I need to do anything more in order to get this data standardized? So it has like a series of things it works through, and then at the end it checks. And if it doesn't, it goes back to the top of the list and it goes down all of them again and again and again and so on. So you can see that it was doing like quite a lot of the code looping that I had to scroll through.
Right.
Yeah.
So maybe at this point we'll move on to Carolina and then we can come back for more general discussion if we have time at the end. Does that sound good?
Perfect.
So we have Carolina Berys Gonzalez, who's going to be talking to us about using LLMs for getting metadata out of texty cruise reports.
Yeah, thanks, Karen. Hi, I'm Carolina Berys, and yeah, I'll be talking about the CCDHO's project to get metadata out of cruise reports. And I do want to start with a shout out. Thank you to everyone who made this project possible and successful. We have some students working on this, Alden Bernstein and Doc Sarov, and also our wonderful director, Karen Stocks, whose vision and guidance made this possible. So thank you. So some of the background and motivation for this project is the CCHDO is a data office and we serve hydrographic data, but along with the data, we have these cruise reports that describe the data, but most of them are in PDF format and they're not machine readable. We know that machine readable metadata is important for fair data practices. And so since some of these cruise reports go back decades, they're unstructured, it seemed like a really perfect use case for LLMs, given how hard these PDFs are to parse programmatically. So our objective with the project is to leverage LLMs to extract metadata from the cruise reports. And we've divided this into two phases. Phase one is focusing on table data, which is already a little more structured. And then we're going to add the text and references. So this project did evolve. Our first approach was a chat interface on the cruise reports. And the way we did that is we turned the PDFs into text using OCR, or optical character recognition. And then we indexed the entire text of the cruise report and had a natural language query on top of that. So we noticed that we were getting unexpected results, and it didn't really address the core issue of the structured metadata to support fair data. So we pivoted to actually extracting the metadata in a structured format from the cruise reports. Our first shot at this, we wanted a pipeline where we put in all 600 cruise reports, and at the other end, we got a giant pile of perfect metadata. And of course, that's not what happened. That's in the real world, the LLMs introduce hallucinations, and we had to commit to having a human in the loop and accepting that we needed expert validation because this metadata needed to be ground truth, and so we needed it to be accurate. In late 2024, OpenAI released the option to have structured output from their LLMs. And so that was another evolution of the project. And that structured output allowed us to add another layer of automated QC and also to employ few shot examples in our prompt engineering. So, oops. Sorry. So a little specifics about the implementation there. So the structured output is based on the Python Pydantic library. And so it's basically a custom schema that the LLM output will adhere to. And that is can have rules-based validation applied to it because it is predictable. And so then the human operator can then look at that validation and make sure that it was applied correctly. If there are any mistakes made by the LLM, those can be turned into example data that then is fed back into the few shot examples, which basically OpenAI offers a prompt template which will select which examples to include based on semantic similarity to the input. So with these strategies, we're actually using the 4.0 mini model, which is incredibly cost efficient. It's pennies on the dollar compared to more larger models that have more context already built in. But because we have this really specific example data, we can use the smaller model and still get really good performance and then have the human validating that output. Also, this is all managed through a custom GUI, and I do want to note it's important because sometimes we have to just omit data. It's not worth training the model to understand some nuance. A good example of this is, so we're looking at principal investigator data. Sometimes there will be like information about maybe the instrument operators on the ship, and we don't want that in the metadata. But it's really hard for the LM to understand, like, this is a person, but it's not a principal investigator. And so we just omit that data. And that's kind of a trade-off we chose. And also highlighting that even just to operate the pipeline, you need some familiarity with these cruise reports. So just putting it all together, big picture, the first step is to turn the PDFs into text with the OCR, and then we're isolating the tables for this phase 1. The LLM is then turns those tables into structured metadata using a custom schema that can then be mapped to other metadata standards. And we're using prompt engineering with a few shot examples to make sure that that output is sound. That output then goes to the automated QC, which is rules-based, and then a human will verify that that automated QC has been applied correctly. And that's all done through the custom GUI, and any mistakes made are then turned into examples that are then fed back for future prompts. So our next steps and our lessons learned, we're done with phase 1, which is in production now, and cruises are taking about 5 to 10 minutes to process, which is great, but that's just been focused on tables that include investigator, float, and instrument data, and then we're going to move on to the text, applying the same procedure but expanding the metadata elements that we're extracting. And the big lessons learned, the structured output was key to enabling this automated QC step, and that the automated QC with the expert validation in combination were really important to maximize our efficiency and also the correctness of the metadata. We managed the costs by using these strategies and also using the few shot examples that let us use the smaller models. So that's all I've got. Thank you so much. If you have any questions, I'm happy to answer them. And then I have some examples of what the inputs and outputs look like.
Can you show the examples?
Yeah, I thought, I anticipated maybe someone might ask.
First examples. And then
so this is just kind of an example, like all the way on the right would be the table as it looks in the PDF. And it's not really even a table. I mean, it's basically, it is text, but it's basically an image. And then in the middle, that's the output from the OCR. So it's not quite perfect either. It's not standardized, but the LLM does a good job of then extracting the specific schema elements from the CSV all the way on the left.
and the schema that you mentioned, the structure schema, it's a schema that you provided. It's based on a metadata schema. What schema is that, and how, I mean, is something you made?
Yeah, so the schema, it's just something that we've made for this process, and then that schema will be, or it needs to be mapped to an actual metadata standard.
I see.
Yeah. It's just for the purposes of getting the information out. And then, yeah, we also map it to like the parameters within the data file. So there's some more processing that will happen afterwards.
And then what do you do with these structured output?
Right now we are TBD. So right. So there's some more steps to this. The end goal is to include them. We do publish CF metadata standard compliant NetCDF files. So it will actually be inside the files in the metadata schema there.
I see.
We are
Nice.
working on developing our metadata model right
I
now.
see.
So
Yeah.
we're
It's kind of
yeah, which
yeah.
standards, you know, do we do ISO? Do we do, yeah, we're working on that.
Nice. Very interesting.
Thank you.
Both projects, they're very completely different, but there's a theme here that is a structure is needed for these LLMs to.
Yeah. You have to guide them.
Have you looked at, because you're not needing an immediate response, right, from OpenAI, did you look at doing the batching?
You know what? Well, yes, we did look at the batching, and that was kind of part of that the automated pipeline, but it is an iterative process with the person kind of in the loop and looking at the output and then doing the prompt again. So
because you could have, I guess you could do like 50 and the person could look at all of them and then it could do the, yeah, I don't know exactly how you structure it, but you might be able to, I mean, I guess you're probably not needing to save money at this stage, but that would make it cheaper, I suppose.
Yeah, so we did try that batching, but it wasn't the workflow with a person looking at each step and then applying the corrections and then running it again just works better as a continuous workflow and being in context of like a single cruise report and then getting all the corrections in. But yeah, the batching.
Is your human in the middle looking at every single one of these? Like every single running their eye over every single PDF and every single structured output?
Every single structured output, yes.
Okay.
And deciding whether it is a valid output or not. And whether the right schema has been applied. So yeah, every single output. But notably, like every input doesn't produce an output.
Yeah, that makes sense.
Yeah. That's a bit of time savings there.
I was just wondering, would it make sense? I suppose probably not. I was just wondering if it helps to loop it through like 2 or 3 times and then compare and see if the results are the same and that kind of thing.
Yeah, I love these questions because yes, we absolutely tried that. That was also one of our strategies, and it ended up being a little bit unwieldy, and it was unwieldy. I would call it unwieldy. We did 5 loops and kind of, had like, okay, 4 out of 5, but it still never really closed in on a perfect sample. Like there was always like discrepancy, and you still kind of needed a human to come in and be the tiebreaker. So it didn't solve enough more problems than it created.
Oh, okay. Interesting.
Yeah, I went through a lot of evolution. Yeah, those are really insightful questions. We tried it. We really tried to get away from having to manually do the QC, but I'll stop sharing.
Well, thank you so much, Carolina.
Oh, wait, sorry, one last
thinking
question.
that eventually you may get out of the human QC and maybe just QC like samples of it, because that's the goal, isn't it? I mean,
Yeah.
yeah, and you will have to live. I believe in these things that you have to live with some errors. I don't think that the more we think that they are absolutely, I don't know, that's my idea.
I think I like I read there's a nice book called Co-Intelligence. It kind of talks about these issues, and a good point is that the LLMs are going to keep getting better. So at some point, yes, we'll be able to trust the output and like, you know, even that it might even be better than a human. So I don't discount that, but we're not there yet
Yeah.
where the margin of error was acceptable for the metadata because it has to be ground truth. And so maybe that will feed into a future model that will be more reliable, but not yet. Yeah.
Or you will have to train and do your own models. That's the thing, that when you're using these LLMs that are not your models, you really don't have a lot of control over them.
Yeah, yeah. And then that was an issue of just of cost for us.
Yeah.
Cost and development time. Yeah.
Maybe you could use the QC data to do like some fine tuning on the OpenAI models, maybe. I was going to ask, do you have the way you've set your workflow up, where you have I presume you have like all the OCR text stored in a database or something. Have you made it easy to be able to run it again in the future on different models? Or, yeah, I was just sort of thinking ahead to when, when models get much better and you're going to be able to do this stuff. And maybe even double check that the human QC person hasn't made any errors.
Yeah, yeah, we have not looked into like other models like Gemini. You mentioned Gemini, and even yeah, we haven't yet. So right now it works and we're getting good results, you know, and so it's checking all of our boxes. So at the time when maybe we need to find a better solution, we might look at doing it something differently. But yeah, right now it's the OCR, it's kind of low tech. We just run it and then we take the CSVs and then run it through this pipeline. It's pretty static.
So the OCR is stored in some CSVs.
Yeah. Yeah.
Okay.
Yeah. And
Yeah.
we do that. We do the OCR through Textract, through AWS, through Amazon, and then those CSVs go to the OpenAI kind of pipeline. So it's not completely automated. We are looking at Mistral.
Oh, Mistral, yeah. One thing I was going to ask was now that they have multimodal modes on the API, did you also think about sending the PDF straight through and it's too expensive or?
Yeah, yes, thought about it. No, have not. Have not made moves in that direction yet.
Yeah. Oh, still, that's a really cool project. I enjoyed hearing about it. Thank you.
Yeah, thank you. Likewise.
Okay, Maria, I think over to you.
So I made a poster to make it easy and quick. So I, as you know, I come to this Council of Data Facilities whenever and in fact, I'm not coming to the meetings because it conflicts with my robotics work. But so I come here because of Design Safe and Digital Rocks Portal, which now morphed into Digital Ports Media Portal. But these that I will show you can be done with any repository that exposes or has metadata, structured metadata. So it's not something that you cannot do. So I don't know how much you know about human-robot interaction data, but it's very different. It's multimodal. It's data that has human subjects data, and it has engineering, robotics, computer science data, sensors, LiDAR, sensors in the human beings, sensors in the robots, instrumentation. I mean, and these are very complex experiments or very orchestrated trajectories that robots do. So more and more roboticists are generating data sets for training, of course, but they don't have a repository, they don't have a metadata schema. So a lot of these data sets are basically on websites, and they don't have DOIs. Their access is hard because these are huge data sets. So sometimes you have to request, getting into a server and downloading, or they do GitHub also. GitHub, it's becoming a little bit of a data repository where they can have a website. I mean, it's all over the place. There's, of course, inconsistent curation, and it's difficult to find these things. So for the Texas Robotics, which is a group at the University of Texas at Austin, which is a group with many, many labs of different types, we decided to use the repository, the University of Texas at Austin repository, which is a Harvard Dataverse instance. And we have a Dataverse there with Texas robotics data. So we started, learning and curating this data. And the first thing was to create a data model. So you see here a data model to understand what is it that we needed to document, what is it that we needed to describe. So, we have to describe the experiments. Of course, sometimes it's not just experiments, it's social science. Sometimes it's not totally an experiment, but it's an observation, trajectories, and all the things that you need to describe to represent the data that is produced out of these complex studies, these benchmark data sets. So this robot model was implemented in a Neo4j database in TAC, in the virtual Texas Advanced Computing Center, in one of their virtual machines. And we started using all the metadata that we produce for each of one of these data sets into these data models, so that we could unify or make these diverse, different data sets uniform through the data model. And all the data can be integrated, the metadata can be integrated. But of course, our goal was really to have people be able to, when you have a repository, in any repository, you have, data set this, data set that, data set this. So you have to open each data set to understand what they have. And we didn't want this. We wanted people to really interact with the system, be able to do comparisons and contrast, and to make broader questions, to make discoverability more like what people are doing now with ChatGPT. Basically, they go from something broad, and then they start fine-tuning, and then they find whatever answer they want. It's a very different interaction than from the search, our search engine that we have in all the repositories. So for this, we call it knowledge integration, and I don't know if you see this enough, but I don't know if you see this enough, but we have all that and another point is that, more and more the students, the researchers are wanting to publish data in the Dataverse collection, which you see a little bit of a snapshot here. And so in order to have them put the right metadata, we created a data template, because the Dataverse, of course, only has data documentation initiative and data site metadata, which is not enough, or is not geared towards describing an experiment. And so we have a data template, and the students start inputting data there as they go through their process about the things that we care, the model robot, the instrumentation of the robot, the questionnaire for social science when it has social science, and all this information. So we have a template. So when they publish the data with the template as well. And so then what we do is that from the Texas Robotic Dataverse and from the data report, we have automated extraction, mapping into the knowledge graph Neo4j. And then we also have related papers sometimes. Some data sets publish papers before or after, it doesn't matter. And that we do manual integration. We use a custom ChatGPT with RAG. We don't pay anything. This is the account that the student and I use, is our instance of a custom ChatGPT RAG. And so the user, with natural language questions, they, interact with the custom ChatGPT. the custom ChatGPT translates to the query language and queries the knowledge graph and the Neo4j, and then returns a natural language answer. Some of the questions, you imagine that you are querying really a lot of data sets. You don't know what you need. You don't know what you want, but you say, maybe what is the robot equipment in bit to real world, or do you have data sets that use this type of robot, or do you have a data set of this kind? And you go from all these big questions until you find something. But these are just examples of questions. How many participants are? This is based on the metadata that we input. And it also retrieves information because, as you know, the JSON file that you can get out of the Dataverse links to all the permanent links of the data. So we can even retrieve data out of this system. We can say, show me all the videos of participant 2, or show me all the videos that were generated in this so-and-so data set, or can you show me the survey instrument used in all of the social science data sets? So, and then you can also compare the differences. What are the differences between one and the other? So I think that the most interesting thing and the most effort that we made was in evaluating this, because we wanted to make sure that this was something that was useful, but also precise. So the evaluation, we did 2 types of evaluation. One is an expert review of the chatbot. And for this, we assess across 4 dimensions. There are information retrieval, answer stability, factual accuracy, and comparison capability. And each one of these has, well, you can do from 10 questions to 100 questions, depending on how precise you want to be, or how good you want to be in terms of your evaluation. And you have to have experts, because the experts, meaning the authors of the data, because they are the ones that can determine whether it's hallucination or not. So they can say, okay, this is exactly what, this data set, this is exactly what happened in this data set. And they were able even to identify when you would ask a question to the data set, and the data set would make, the ChatGPT would make inferences based on its own knowledge. So the questions were, the answer was correct, so to speak, but it was not used, that terminology or that instance was really not used in that specific data set. So the chatbot is reviewed by experts in a very structured way. As you can see, we have very good accuracy, 4.9 out of 5 answers in stability. And the experts, we did also the scores. Each one of these questions were rated from 0 to 5. We did adjustments with Bayesian hierarchical model to test objectivity. And it was it was deemed as a reliable tool, as a useful resource for HRI researcher for finding these answers. And it did outperform the keyword search in terms of being able to get into the data and find out exactly a lot of things about the data themselves, the data itself, as opposed to just one querying, looking at one data set, or having to read a data report, a huge data report, which happens when you do experiments. And then we did a pilot Think Aloud session, and that was researchers that had no clue about these collections. They were roboticists, and Rukaya, I don't know if I'm pronouncing well your name, but these people do like to talk to chatbots. They do know how to interact with chatbots. They are very savvy in terms of how they they talk. I'm surprised, because some of the questions I cannot understand that they do to the chatbot. And also the way that they say, hey, don't tell me this. I think you're exaggerating, or I don't want so many words. Can you please be more precise or more concise? Just tell me, but you said this, and I, it's like a complete dialogue that they do. And they are very savvy in terms of chatting. And they also deemed this very useful for them. And they even made recommendations. Some of them were a little bit annoyed with the verbosity, but they were pleased with the results. And they gave us some recommendations to improve this. So this is where we are right now. This is a prototype. We are using the very limited ChatGPT, free ChatGPT for students. But fortunately, TAC is implementing a system that is called Samba Nova that you can even compare across various LLMs, and it doesn't have any limits, meaning, because sometimes here you say, give me all the videos from participant 3 in this experiment, and because you start with, how many sessions has this experiment, how many, times you tested this or whatever. And if there are 5 videos, maybe it can only retrieve 2 because of the limitations of the usage of the system. So this summer, we are going to transfer these into the Samba Nova system with other natural language models. And we'll test the scalability. But we are happy. So far, we are pleased with this. And we think it can really change the way in which users can explore data sets. Of course, the caveat here is that you really need good metadata. You still need curation and you need structure. This knowledge graph gives the structure because we did experiments with and without the structure. And without the structure, you don't get the relationships. We don't get the comparison. And also, we don't get the uniformity across data sets that allow you to, cross-reference these data sets. So the curation, the metadata that people have to implement in this template or wherever in the repository still has to be very complete in order to have good results. So I don't know if you have any questions.
Thank you so much, Maria. If you would be willing to share the poster, I would love to have an opportunity to read it through again.
Mm-hmm.
Any questions or comments?
Yeah, that was really interesting. I was just wondering, so you were using the RAG and you had your knowledge graph. Did you also try any of these LLMs which have these really, really long, super long context lengths, like a Gemini, for example, where you just feed it everything and then you don't bother with like structuring stuff and it's just like splurge data?
No, but I think that when we did without the structure, we were getting very incomplete results, especially because we were trying, as I say, you're asking not just about one data set, you're asking about many. So you need something to unify. There's a model that unifies this language, method means method for all the data sets. When we are talking about the settings, the experimental settings, it means the same across all the data sets. So the knowledge graph is what links this data set with this other data set, even though they are different. And maybe some data set doesn't have settings, so we know it doesn't have settings, and so it gets, it doesn't get, so it's not a put everything on. We tried putting everything on, just the data report without the knowledge graph structure, and it didn't, the results were very inconsistent and incomplete.
And out of interest, how many users are you expecting?
Right now, we cannot have many because of this limitation. That's why we are moving these to, I mean, ideally, to be sincere, the goal of this would be, let's say, design safe. We have this implemented and any user can go and, you know, chat and get whatever they want. And design safe has, you know, a big user base. That would be the ideal. Right now, it's impossible, but that's why we are moving this into the Samba Nova hardware and other LLMs that are not the OpenAI LLM. They're the open source LLMs, and we will see. We will see how scalable this is. But that's why I work at a supercomputing center. So we're supposed to be scalable. We'll see.